Hello buddies, how are you all? Welcome to Mona's Cat Solution. Today I'm going to deal the topic called stress strain curve. So we will deal with this topic because this is very important. Every point in it is asked in each and every exam. So let's go through it to learn detailedly about stress strain curve. Stress strain curve is different for different materials. For ductile materials, it's like this, and for brittle materials, it's like this. So first of all, we will learn about the ductile materials. Before going to stress strain curve, we will detailedly know what is stress. Stress is nothing but internal restoring force. It's a ratio of applied force to the cross-sectional area, and its units are Newton per meter square. Coming to strain, it's a fractional change in configuration, that is a change in length, the original length. It is a dimensionless because a change in length, the original length, the units get cancelled. For ductile materials, we have some points marked on the curve. So we'll detailedly go to the points. So first, O to A is a proportionality limit. It's nothing but stress is directly proportional to strain. So how amount of the load is added, that much amount of the elongation is done within that O to A limit. From A to B, it holds the elastic limit, means it is beyond the proportionality limit, and as the load is applied, it elongates. But if we remove the load, it gets back to its original position. From B to C, point C is called upper yield point. It's a plastic deformation, where from B to C, plastic deformation gets started, and it widely takes place in the portion of B to C. From point C to D, D is called a lower yield point. A strain is more at point D than point C. C, we can see that a strain curve is more deeper at point D than at the point C. So it's also a plastic deformation, absolutely no doubt at all. From D to E, point is called yield point, which is called ultimate tensile stress, where stress is maximum. Yield point is a point where stress is maximum. You have to remember, because see, in the curve we have a yield point as a maximum point. From E to F, stress decreases, but still strain increases, and at point F, the material breaks. Is called a breaking point. So these points, what I mentioned here, are important because from B to E, they will ask in exam what is upper yield point, what is lower yield point. See, in lower yield point, stress is maximum. You have to remember it. Okay. That's all about the stress strain curve. This shows that how a ductile material behaves when a load is applied. In ductile materials, it intimates that material is getting damaged due to increasing stress. So we forcefully move towards a brittle material, and for brittle material, we have only 2 points. It's O to A, approximately proportional to limit. A to B, stress strain both increases. See, from O to A to B, and where when the point reaches to the B, it breaks or sudden failure occurs. Brittle materials develop internal cracks first, and then cracks reach up to surface. So we should ensure that internal cracks occurs first. So usage of brittle materials need much more inspection than usage of ductile materials, because it may break at any point if the load exceeds beyond the limit. So sudden failure of material takes place, which is very dangerous. So studying these two stress strain curves, uh, these two types of materials is very important because they were asked in many exams, and uh, in general point of view also selection of loads or materials, this curve takes place a vital role. Okay, so feel that you understood this. Thank you. Please share.